right, snowfall on a driveway. Janet, snow begins to fall at midnight. From midnight to 9 a.m., the snow accumulates in the driveway at a rate that can be modeled at 7t e to the cosine t cubic feet per hour, where t is measured in hours since midnight. Janet starts removing her snow at 6 a.m. She waited till 6 a.m. to start, so she is not shoveling before 6 a.m. Inclined kids, you understand what that means. There's no shoveling happening yet. Right? She's going to wait until 6 a.m. So it's just falling. It's piling up on her driveway. The rate, G of t in cubic feet, which Janet removes the snow on the driveway, is written in the following way. So if you look at her, Janet is removing snow at a rate of 0 between 0 and 6 hours. Why? She's not shoveling. Between 6 and 7, she gets out there and she's a machine, 125 cubic feet per hour. Boom, 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 boom. She gets tired, and between 7 and 9, she brings it back down to 108 cubic feet per hour. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? Okay, so how much, given a rate at which snow is falling, how much snow is on the driveway? Well, we know how to do this, okay? Again, now, if you're going to cheat and use your calculator, which you would have your calculator for this part, and you'd have to use your calculator, I lie, not cheat, you'd have to use your calculator, from 0 to 6, 7t e to the cosine t dt. Why do I say you use your calculator? Good luck. U equals cosine t ain't going to be solved by this. There's nothing that's going to get you out of this mess. So you slap that in your calculator, you hit equals, and if you do it correctly, you should get 142.275 feet cubed. All right. Done. That's so easy. Look at that. Put in your calculator, hit equals. We're rolling. Find the rate at which the volume of snow is changing, right? Change in the volume of snow on the driveway at 8 a.m. Now, there's two problems here. What are the two things going on? Well, snow is falling, but she's shoveling, right? So the rate at which it's happening would be the rate at which it's falling, which is going to be 7t e to the cosine t minus the rate at which she is shoveling, right? So what would that be in this case? It would be 7t. We're talking about at hour number 8, right? Change the rate at 8 a.m. So 8 e to the cosine 8 minus g of 8. Well, at 8, she's removing snow at a rate of 108. So therefore, I slap this in my calculator, and I get negative 59.583 cubic feet per hour. So in other words, she's shoveling faster than it's falling, which is a good thing to have happen in your life. C. H of t represents the total amount of snow in cubic feet that Janet's removed from the driveway from time equals t after midnight. Express H as a piecewise defined function. Why? Because she's changing what she's doing. How much snow is she removing? Oh, crud, this is going to become hard. Why? Because our time's all screwed up. We're not starting our shoveling at time equals 0. We're starting shoveling at time equals 6. All right, fine. Well, it should be okay for the first little bit. H of t is going to be equal to 0. She's removed 0 snow from 0 to 6 hours. She's got no snow so far. Now, things get interesting. How much snow does she remove at 7 hours? Well, we know at 7 hours she's already removed 125 cubic feet, correct? And we know she's doing it at 125 cubic feet per hour. So we have an equation for a line, 125. And you might think, well, why can't I just put a 125 times t? Well, if I put 125 times t, when I put a 6 in this equation, I get she's already shoveled 750 cubic feet. That won't work. And yet that's got to be part of the equation, doesn't it? So how are we going to do this? Well, what we're going to do is we're going to say we're going to do our official integrating the way we should. Okay? So here's our integration. Integration 125, what's our rate? dt would give us how much snow she's lifted, right? And if I look at that, I raise the power by 1, divided by the power I get, plus T, right? And the one place I know is at 7 hours, she's going to have done 125, correct? I could also, by the way, plug in 60, couldn't I? Because I know at the beginning she's doing 0, right, during this stretch. And so that's the amount that she's pulled. So then I plug in, you can plug in a 6, I'm going to plug in a 7 because that's the first one I came up with. 125 times 7 plus C should give me 125, right? So that's 700, 875. Plus C should give me 125. And so C should equal negative 750. So she should have 125 T minus 750, right? Plugging this back in for the constant, okay? And that should be between 6 and 7. At 7, she's going to suddenly change her rate again. So we're going to have to deal with that in just a second. Now, let's double check. If I plug in a... And that didn't work. Oh, no. If I plug in a 0. No. If I plug in a 6, right, I get 600, I get 750 minus 750, so she's done nothing at hour equals 6. When she first gets out there with a shovel, she's done no shoveling so far. When I put in a 7, I get the 125 I'm looking for. All right, so now I move forward and go, aha! So I can see my pattern. It's going to be 108 times T plus some constant. So I go over here, 108 times time plus a constant has to give me, okay, where do I know? I know at 7, she needs to start having 125, right? So I'm going to put 125 here. I'm going to plug in a 7. So I got 108 times 7 plus C must equal 125. And so 7 times 108. Minus 125, and I get negative 631. And so I'm going to come over here and go minus 631. Is that really 108? It's really 108. So that's between 7. Make one of these an equals. It doesn't matter which one, actually, in this case. 29. All right. And that is how much she has shoveled for any time T in the future. All right, that was a hard problem. We got it. How many cubic feet are on the driveway at 9 a.m.? Well, that's pretty straightforward. Now that we've done all this work, I'm simply going to say the amount on the driveway is going to be the integral from 0 to 9 of 7t e to the cosine t dt minus, and by the way, I would probably, just because I'm nervous about math always, I'd say she did 125 during the first one, plus she did another 2 times 108. You could use this equation. You can even go back and integrate the thing from scratch. Kind of don't think I want to do that, so 216. So this would be, she shoveled out 341 cubic feet. Throw it in my calculator, and I would get 26.335 feet cubed. All right, and so that is the answer to the question. How much has she done? And that is the second free response question of this set. So again, stuff comes in, snow's falling, I'm shoveling, consider the rates, and so forth.